For centuries, the rise of humanity has been marked by the ascent of intelligence. Our journey from humble beginnings to our current dominion over Earth wasn't guaranteed or even predictable. Intelligence, this special capacity for learning, reason, problem-solving, and knowledge acquisition, became our greatest asset, incredibly rare and exceptionally costly in the evolutionary game. But it proved so powerful that it allowed us to change the very rules of nature and claim control over our world in ways no other species ever had. Yet this climb was anything but straightforward. The earliest stirrings of intelligence emerged over 500 million years ago in the simplest organisms, flatworms with clusters of just a few neurons orchestrating basic processes. The story of intelligence was, for eons, a tale of gradual adaptation as life diversified and grappled with ever-changing environments. Brains are expensive, and for most creatures, survival meant evolving narrow minds tailored for specific survival tasks. Advanced navigation in birds, problem-solving in octopuses, social complexity in mammals. Each flourished where the costs of greater intelligence were offset by the benefits. Something extraordinary happened around 7 million years ago. Among our ancestors, the hominins, brains began to grow faster and more complex than those of their close relatives. The transformation from narrow, specialized intelligence to more general cognitive power was underway. By 2 million years ago, beings like Homo erectus were peering at the world not just as something to endure, but as something to shape and understand. They harnessed fire, shaped tools, and spun the first threads of culture. Eventually, Homo sapiens emerged about 250,000 years ago with even larger, more sophisticated brains. What set us apart was not that we could simply remember or imitate, but that we could ask why, to endlessly wonder, to communicate nuanced ideas, to collaborate on ambitious endeavors. Each insight gave rise to new questions, sparking a feedback loop of knowledge accumulation that genetic evolution could never match. Discovery built upon discovery, progress accelerating in fits and starts, agriculture, writing, mathematics, medicine, astronomy, philosophy, each an explosive leap compared to the slow crawl of biology. Just 2 centuries ago, the scientific revolution gathered speed, making humanity dramatically better at learning and innovation. The internet, a mere few decades old, connected the planet in real time. Today, our lives are profoundly shaped by our intelligence, tailored through countless inventions and systems designed to serve our needs. This is a recent development in the grand sweep of time. It's easy to forget how unlikely, how hard-won, and how abrupt our rise truly is. Now, as we stand on the brink of another transformation, we are about to create something that could fundamentally challenge our unique status: artificial intelligence. Software that performs mental tasks with astonishing speed and skill, using silicon chips instead of biological neurons. At first, AI was little more than academic curiosity, lines of code on 1960s paper, built for narrow demonstrations. The first AI chatbots and search programs were novel and limited tools, requiring specialized knowledge to operate and applicable only to tightly defined domains. These early AIs were mere shadows of intelligence, the mental equivalent of flatworms, capable but spectacularly restricted. As decades passed, progress stalled and surged in waves. But the relentless advance of computing power, growing a billion-fold between 1950 and 2000, quietly laid the groundwork for the next leap. AIs learned to navigate simple rooms, recognize handwritten digits, and even play chess at world champion level. Each triumph was met with a rationalization. These were just highly specialized tools, nothing close to human thinking. But in their domains, whether chess or facial recognition, AIs grew unbeatable, forever outpacing the most skilled humans. The real breakthrough came when we taught AIs to improve themselves. Today's AI is built on massive neural networks, vast webs of virtual neurons that, with enough training, achieve levels of performance previously unimaginable. Powered by supercomputers and oceans of data, machine learning unlocked generalizable approaches to complex problems. These new AIs could master tasks quickly, adapt to changing data, and most disturbingly to some, learn in ways we don't fully understand. By the mid-2010s, AI was scoring victories in fields like image recognition and the ancient game of Go, besting grandmasters with startling creativity. In hours, some AIs trained themselves to superhuman levels simply by playing against copies of themselves, surpassing older programs and human experts alike. AI began permeating daily life. In social media recommendations, customer service, banking, healthcare, marketing, and content generation. The release of advanced language models, able to converse and generate text indistinguishable from that of a human, marked yet another milestone. But today's AI is still narrow. It excels when trained for a particular type of task, but lacks genuine understanding across different fields. While modern language models can summarize, translate, and solve math problems in seconds, they do not truly understand in the human sense. The next step, artificial general intelligence, or AGI, could change this dynamic forever. Where existing AI is a specialist, working within tightly bounded domains, AGI would be a generalist, capable of learning any intellectual task that a human can, and perhaps many more. It's possible that, with continued advances in hardware and algorithmic design, AGI may not only match human competence but far exceed it, learning rapidly and performing tasks with a speed and economy humans cannot hope to rival. Imagine for a moment what happens if AGI is achieved. Software that can be copied and run in parallel, thinking and reasoning faster than the sharpest scientist, lawyer, or artist. While there are 8 million scientists working in the world today, AGI could be replicated a million times, working 24/7, tirelessly solving our greatest challenges, or perhaps taking over that work entirely. The potential benefits are enormous. AGI could accelerate scientific discovery, cure diseases, design sustainable energy sources, or tackle climate change at a scale and speed never before possible. It could liberate us from tedious work, giving us new opportunities for creativity and fulfillment. But the risks are just as immense. If AGI is misused or its aims diverge from humanity's, it could create economic upheaval, social instability, or even existential threats. The pace of AI advancement could rapidly lead to an intelligence explosion, a scenario in which increasingly capable AIs design their own successors, improving themselves at dizzying speed. This recursive loop could yield a superintelligence, an entity whose cognitive abilities so radically outstrip our own that we could not foresee or control its actions. We have no guarantee of a benevolent outcome, nor assurance of doom. All we know is that for the first time since we looked up at the stars and wondered about our place in the world, we stand at the threshold of creating something fundamentally beyond ourselves. The future, once again, is in flux. Still, there's time for thoughtful preparation. Understanding artificial intelligence, how it works, what it can do, and how to use it responsibly will be one of the defining skills of our age. The race is on, not just among companies and countries, but within ourselves, to ensure our intelligence, our wisdom, keeps pace with the tools we are about to unleash. Did you find our videos helpful? Please like and subscribe to our channel so we can be motivated to answer the questions that people are still wondering about.